Hope something is seen on the screen. Did you see something on the screen?
Yes, sir.
Yes, sir. Late magmatic deposits.
Okay. Okay, please write down. What is written there? Just write down. I am just coming in 2 minutes time. Please write down. Take your notebook, take your pen and write down. Start writing. Yes. Send it to the mail, send it to me as well as for GTS. And I will also go through. Then please join. Yes. Akshat Punia.
Yes, sir.
So what is written here?
Sir, late magmatic deposit.
Okay. What is there? After that, what is it written?
Sir,
What is given this? Hmm.
ore minerals from a residual magma end of the magmatic period left after exfoliation of early silicates.
Okay. So this is one point. Okay. So there are certain terms. What is residual magma? Can you please tell me?
Sir, the magma that is left after crystallization of early magmatic deposits.
May I know who is speaking?
The rhythm.
I did not ask with them.
Oh, okay, sir.
I did not ask with them. I asked Mr. Punia.
Yes, sir.
Please tell me what is this ore minerals from residual? What do you mean by ore minerals from residual magma?
Sir, this means, sir, the basically the magma which is left
Which is
after, sir, which is left after, matlab, means, sir, which is not recently formed, sir. It some time has passed.
can you give me an example? Can you give an example? Suppose let us start with the magma. Where you will call it as early magma and when you will call it as a residual magma. Give me an example. Let us take a basaltic magma. When it will become
Yes.
early magma and when it will become residual magma.
Sir, it will be early magma when it is formed beneath the surface, and when it come out of the surface, it can be residual magma.
Oh God. So do you know there is a term called volcanism? When it comes out to the surface, that's called as volcanism. That's not called residual magma. Now let me talk to Amit Srivastava. Mr. Amit Srivastava,
Yes, sir.
what do you mean by early magmatic crystallization?
Sir.
What exactly happens? For example, now we are talking about late magmatic. Okay. The last class we discussed about early magmatic process. What do you mean by early magmatism? What all happens in early magmatism?
Early magmatic.
What all happens in early magmatism? What all happens in late magmatism? Can I talk to Anshika? Anshika Bong?
Yes,
Can you tell me? Can you tell me what happens in early magmatic crystallization and what happens in a late magmatic crystallization? Take one example
I
of a
didn't attend last class, but I have studied that.
No, no excuse, no excuse,
The
no excuse,
deposits which,
no excuse at all. Whether
sir,
you attend the class or not attend the class, you are
yes,
supposed to know certain basic things.
yes, sir. So when the those deposits, those magmatic deposits which form simultaneously with the host rock are called
With
early
with
magmatic
with
deposits,
what?
and
With what?
the late
Just listen. With what did you say?
it form, it forms along with the host rock. Like
Magmatism
late
itself is
magmatic forms
late
later
mag.
on.
Early magmatism itself is host rocks. What are you differentiating between between mineralization and the host rock? I did not ask anything about mineralization.
So
I
it
asked
forms
what happens in early magmatism. That's all. Suppose you take a basic composition of ultramafic magma. What all happens in early magma? Instead of simply saying, "Sir, I do not know," you are throwing big things. Don't throw big things. If you say yes, you say yes, I know. If you don't know, you say, "Sir, I do not know."
So
Akshat?
I don't know much. I just know that
Okay.
it
Enough.
happens
I
simultaneously.
listen to you. Try to read something. Try to read something. Try to read something. Takshat, what is his name?
Yes, sir.
Taksh Jaglang. What happens in early magmatic crystallization? What all happens? Last week we spent about more than an hour to study early magmatism. Suppose let us consider you have basaltic rock or a magma, ultramafic magma. What all happens in early magmatism? So it shows that none of you are reading anything. May you know one student who can tell this, who can answer this question? Your name, then you can talk.
Nikhil speaking.
May I know a student who can tell
Um,
what happens? You take an ultramafic magma, which is to start with. Let's consider it can crystallize a dunite or a peridotite. What all happens in this particular crystallization?
Nikhil speaking. So can I
Yeah,
answer?
Nikhil, please. Nikhil, yes, okay. Please tell me.
Sir, for early magma
Hmm.
crystallization, we can say that it's the first time a magma start crystallizing, forming
Okay.
crystals
Take
which
an example. Take an example of a magma.
basaltic magma when
Basaltic.
it
Okay, yes, very good. Basaltic magma. Yes, tell me what all when
when
early crystallization, what all happens in basaltic magma?
so when it start crystallizing the crystals with the high iron magnesium content like olivine and pyroxene start crystallizing, and then when they start settling, and we see a sequence of bedding formed because of the crystallization.
Mm-hmm.
Magma with high silicon percentage left, which
Have
is
you have you ever come across a basaltic magma giving so much of olivine? Have you ever come across a basaltic magma which can give rise to so much of olivine?
sir at mid-oceanic ridges, we can say.
These are all throwing things. तो
Sir,
हिंदी में बोलता फेक ना इसको बोल हिंदी में बोल लो फेक ना. Do you know what is
नहीं
the
सर
composition
उसमें
of basalt?
एग्जांपल था उसमें करना.
Do you know what if you take a basalt? What are the minerals? Do you see? Do you know?
It's 40 to 50% of silicon oxide and
Silica. What do you mean by
silica,
silica? What do you mean by silica?
SiO2.
SiO2. SiO2 is it a mineral?
No, it's a compound, and it
If I
forms
see,
chains and
if I
form.
say what is the mineralogical composition of basalt, will you say 50% is silica? So that means you do not know what is the difference between silica and silicates.
Okay, silicates are chain of silicon.
So that means you do not know what is chemical composition, what is mineralogical composition. If I say what is the mineralogical composition, basalt, will you say 50% silica? Nickel. What are the grades that you got in basic petrology or in petrology, igneous petrology?
Igneous petrology 10.
10. You got 10. I will write a letter to Dean. I will write to Sandeep Singh that just take back this grade from you.
Sorry, sir.
First read basalt. Read basalt, mineralogy of basalt.
Yes.
After this class, read about the basalt mineralogy. These are the conditions of for student getting 10 out of 10. And how do you, I can imagine what is the condition of others. What is the residual magma?
Sir, the magma that is left after some crystallization of mafic minerals,
Okay, so what the residual magma will be composed of? Mostly
mostly felsic minerals,
felsic minerals. Can you tell the example of felsic minerals?
uh, such as quartz, hornblende.
Hornblende. Hornblende is a felsic mineral.
Yes, sir.
What is the composition of hornblende? ये मैं क्या पढ़ा हूँ मैं? What to teach? You say hornblende is a felsic mineral. क्या पढ़ा मैं? Try to read. Try to read. Upload first. All of you, please write an assignment on magmatic crystallization with special reference to Bhavan's reaction series. I want all the students that this should be submitted on Thursday evening. All the students of GLT, GPT should write an assignment for about 4 pages on magmatic crystallization with special reference to Bhavan's reaction series. Magmatic crystallization with special reference to Bhavan's reaction series. This should be submitted by Thursday evening. Minimum 5 pages. Okay, 4 pages. Let's call 4 pages. Okay. Here you go. I could see the condition is bad. Okay. So anyhow, last class I did teach about the early magmatic crystallization. So in this class we will try to talk about the late magmatic crystallization, and because of that you do have certain mineral deposits forming. So in early magmatic you will have a set of minerals forming. Is it right? And once the early minerals are forming, the magma changes its composition. So naturally the mineralogy of the magma will keep changing. Okay, all right. So during that particular stage, if some ore minerals are forming, okay, after the crystallization, early silicates. So first you people should know what is the difference between silicon and silicates. Silicon is a chemical composition. Silicates is a set of minerals having silicate structures. Okay. So in this process, the ore minerals will be forming, and these ore minerals will be later than the silicate crystals. That means in this particular process, you will have the early form, you will have to start with the silicates will form, then the ore minerals will form. So during this process, it will develop a lot of reaction rims. So reaction rims are something like this. You will have whenever a mineral is forming and the magma is still there, and both of them will react and they will form the rims. And this type of process is associated with mafic igneous rocks. All right. And in this process, you will have, it's called gravitative liquid accumulation. Of course, I don't call it as liquid, I call it as melt always, but in the standard books like Bateman, it's always given as liquid. It is basically a melt. So you will have certain melt accumulating at the bottom because of gravitation, but late stage, not in the early stages. So that can give rise to residual segregation, residual injection, and another one is immiscible liquid. Of course, we will talk about immiscible a bit later. And immiscible liquid further divided into segregation as well as injection. So you will have settling down as well as the injection process giving rise to this type of late magma deposits. But here, if you try to see the rocks, you try to study them under the microscope, you will have the early formed silicates, then the late formed ore minerals. Whereas in case of early magmatic, you will have the early formed minerals at the same time early formed ore minerals. The petrography will tell us.
Sir,
Yes?
sir, what you just said about silicon and silicates, can you repeat?
Yeah. Silicon is Si. Si is a chemical component, whereas silicates is a group of minerals having the structure. Okay, it's called silicate structure. So they're called silicates. It's a group of minerals, whereas silicon is a Si, which is a chemical component. One is mineralogy, another one is the chemical composition.
Okay, sir, thank you.
So in this process, we will have iron titanium ores of Bushveld. Okay, in Bushveld, you do have the chromite. At the same time, you have iron titanium ores. The Bushveld chromite is early magmatic, whereas the iron titanium is of late magmatic. Magnetites of Kruno in Sweden. The pegmatites, most of the pegmatites in different parts of the globe. The nickel copper sulfides of Inzizua, as well as in Sudbury. Inzizua in South Africa, Sudbury is in Sweden. Sorry, in Canada. So all these deposits, they form part of the late magmatic process. So how do you distinguish? The early magmatic deposits, they lie within the igneous body at the place of settling. You will not see any mobility. Whereas in case of late deposits, you will have accumulation through mobility, which will be seen in the form of cutting across structures. Whereas in case of your early magmatic, you will not see any cutting across internal structures. So these are the two distinctions that differentiates the early magmatic deposits and the late magmatic. In case of early magmatism, you will have settling and no mobility, whereas in case of the late deposits, the accumulation takes place because of mobility. And in this, you will have a lot of cutting across structures, whereas in case of the early magmatic, you will not have, they will be purely stratiform. What exactly happens inside? You will have mafic minerals crystallizing first. As one of the students said that residual magma enriched in silica. Is it right? Is the chemical composition, Si, alkali, sodium, potassium, water, these are all chemical constituencies. Because of the difference in chemical constituencies, the resulting minerals, the silicic minerals, will form at the last. Quartz, feldspar, muscovite, these are silicic minerals. Hornblende is a mafic mineral. Pyroxene is a mafic mineral. Okay. So in this process, certain mafic magmas which will have residual component which are rich in iron, titanium, and volatiles. When such a thing is happening, you will have certain calcic plagioclase developing in the magma, and these crystals having lesser density, they will try to float. The early formed, whereas the early formed will sink, the mafics will sink, the late formed will start floating. Mafic crystals early formed will sink, whereas the calcic plagioclase, which are slightly later, they will start jostling upward. That means they'll start floating. In this process, you will have mush of crystals with a diminishing liquid. That means the liquid, the melt component, will keep on decreasing. So in this process, the residual liquid, or called the residual melt, will be rich in iron, okay, where the density of this liquid is higher than the jostling minerals like calcic plagioclase. So all these things happen. I'm just going to show one diagram which is very clear. Yeah, this particular diagram. This is a wonderful diagram. Okay, so this is what happens in a early magmatic. So you will have a chill zone, which is very common in most magmatic deposits. The bottom one is a chill zone. So because when suddenly the magma is intruding into adjoining rock, the adjoining rocks will develop chill zones or chill origins, which will always be there. But if you see the one, okay, you have the melt with early formed crystals. Is that right? The early formed crystals are forming at the bottom. Whereas here, the late formed crystals are forming, and you will have a lot of iron titanium containing small liquid, high dense liquid in these places. So this liquid is having higher density, so it will not be the inside remaining. It will start flowing down. It will start flowing down, then it will form a layer. See, the late formed ones will all be pushed up. This is early formed one, this is late formed one, and in between, whatever the liquid is remaining in the interstitial spaces with a very high iron titanium, they will all come and form here. They will all come and form. So these called as residual liquid segregation. You will find few minerals inside also. When you take a rock of this particular part and try to do the thin section studies, you will find out that the late formed ore minerals are cutting across the early formed silicates. A lot of things you will be able to see. And if it is subjected to injection, then it will go out, because many times filter pressing, like you have a sponge, inside you have a lot of liquid and it is compressed, because all the geological process doesn't take place in a simple environment. Many of the magmatism takes place in a highly stressed environment. So whenever there is a stress operating in tectonically active zones like the Himalayan subduction zone or any other alpine mountain orogeny, okay, whenever a melt is forming in an orogenic environment, it's subjected to compression. So because of this, they will get injected. That's why it's called as residual liquid injection. This is called residual liquid segregation. So these are all the late stages of magmatism. This one is early stage magmatism, whereas all others, for example, this one, these are all late stages of magmatism. The things are better now. Aryan Gupta, Mr. Aryan Gupta,
Yes, sir.
things are better now.
Yes, sir.
Able to get something out of this picture? Please, all of
Sir,
you, please note down this picture. Please draw a diagram. Please draw a
okay,
diagram.
sir.
All of you, take a notebook, take your notebook, a sheet, and start drawing this diagram. Have you drawn the diagram? Mr. Danvin? Mr.
Yes,
Danvin?
sir.
Have you drawn this diagram?
Yes, sir. I'm drawing.
Okay, please tell me when it is over.
Yes, sir.
Please. Have you got Bateman book with you? How good if you have got Alan Bateman? Daksh Jaglan with the meeting. Jay,
Yes, sir.
how far you have come in drawing these figures?
So almost done.
Almost done. Okay. If you have a book called Bateman, it's a beautiful book. I don't know if it's, you can get it from some of the websites, called as Economic Geology by Alan Bateman, Jensen and Bateman. It's a wonderful book, very old book. It has undergone a number of editions. So if you can get it from somewhere, from some website, you please download. That book has got these beautiful stages. It gives the various stages of magmatic process. Whatever the dots that you are seeing here, they are all the iron titanium rich belt. So they will all start flowing down. Since they are having very high density compared to the adjoining minerals, they will flow down and they will form a layer. So this layer is called segregations. So in this process, some of the late formed minerals will be trapped inside some of them will be pushed up. So in this process, you will see a lot of cross-cutting structures. And when it is compressed, it will all inject. The most famous pegmatites. Pegmatites are all because of the injections. Number one, they are residual magma and they're injected. Always they will be all injected. Garima Garg. How far you have drawn the diagrams? Okay, please. Yeah, good. I'm happy. Yes. In this way, like you people will be busy in doing something. Instead of simply listening to lecture, this type of noting down, drawing diagrams, all will be very useful. How many of you have completed drawing?
Done, sir.
Done?
Yes, sir.
Done, sir.
Completed.
Okay,
Yes, sir.
Okay. Let me go to the next slide. Okay. So when such a crystallization takes place, there are two possibilities. The silicate crystals will touch each other, and whatever the liquid is in between, that will freeze. Like no, I showed that there are a number of crystals are there, and in between the residual liquid is there, and because the density is higher, it will start flowing. Suppose during its flow, the crystallization takes place. Let us consider. Then what will happen? It will give rise to interstitial pores. That means you will have silicate crystals. You will have silicate crystals. I'll have the pen. You will have the silicate crystals, and you will have the ore in between. And when this freezes, it will give rise to ore with certain interstitial minerals. Okay, this is first stage. Okay, heavy liquid drain downwards. Yes. Okay, and it will segregate or early formed sunken crystals. So you will have the magma chamber, you will have early formed minerals at the bottom. So when the late formed minerals are forming and when the liquid is there, it can drain without freezing, it can come down and it can form stratiform layers. That is second choice. So in this process, the light crystals will float. Yeah, yes. The light crystals will start flowing up, okay, and pushed upwards. So in quiet conditions, the heavy liquid will form a concordant layer, this like this. Like this, it will form a concordant layer. But still you will have certain minerals. in between. Whereas in case of early magmatism, you will have pure chromite. Whereas in this late magmatic, you will have certain minerals inside. So, and another condition is that whatever the liquid is there can be injected also. That is squirted out, injections. So all these possibilities are possible. Either it can give rise to interstitial ore, or it can form at the bottom, or it can form as a injections. So all these things are possible. Okay. The next one is called differentiation. Of course, probably you must have studied in igneous petrology. Okay. Differentiation causes a concentrating effect. You must have studied differentiation, highly differentiated magma. Okay. So here the differentiation causes concentrating effect. Okay. And the concentration of selected elements in the residual magma takes place. It typically is granite, pegmatite. When a granite starts crystallizing, let's consider granite magma is there. So it starts crystallizing. It will have muscovite. It will have feldspars. Then it will have quartz. Okay. So the residual liquid will be more and more enriched with a lot of volatiles, a lot of SiO2, a lot of other components. Okay. And when that is injected, it will become a pegmatite. And these pegmatites are very important for certain important minerals: tantalum, niobium, tin, tungsten, uranium, molybdenum. So if you want to explore in the pegmatite these type of metals, then you have to look for a highly differentiated granite. Studying granite mineralogy and petrology will be useful to understand the concentration of tantalum, niobium, tin, tungsten, uranium, molybdenum. So these are very important. That's why when you are going exploring any deposit, it is a must to understand the mineral forming process and the rock forming process. Very important. So that's why we are studying all these things. What are pegmatites? They are coarse-grained igneous rocks. They form at the last stage of crystallization. They contain accessory minerals of special interest because they trap a lot of rare earth elements in the crystal structure. All are very important nowadays in the industries. Because of the rarity of some of these elements, the accessory minerals in the pegmatite can be quite valuable and constitute a ore deposit. Of course, pegmatite can also form a mineral deposit like mica. At the same time, it can form a ore deposit like tin, tungsten, uranium. Sometimes you will have the rare metal pegmatites, okay, niobium, tantalum, columbite. All these things are very important. That pegmatites host a lot of important metal as well as mineral deposits. How many of you have seen a pegmatite sample? Iftikhar Hussain? Mr.
No, sir.
Hussain?
No, sir.
No. Where are you from?
Sir, I am from Ladakh.
Ladakh, oh God, oh. But in Himalayas, you do find some pegmatites, but you are far away. Ladakh will be having only ice, filled
Yes.
with ice. If you come down slightly below, then there are certain places where exposures you will have pegmatites, higher Himalayas. Okay, all right, no problem. If you happen to come to our museum, did you see in the museum these pegmatites?
No, sir.
No. Next time when you come, please see all these things. Okay.
Yes, sir. Sure.
The another important process is the lake magnet is called liquid immiscibility. Just like you take a test tube, you take water and you put a drop of oil separate and water will separate. This is called liquid immiscibility. Is it right? All of you are quite good in chemistry. It's called immiscibility. Is it right? The same thing happens in a magma also. People have understood that a magma also can have this type of process. Especially we are talking about sulfide immiscibility. Of course, you have oxide immiscibility also, but sulfide immiscibility was the first process geologists were able to understand. So geologists are studying Hawaiian lavas. As you know, Hawaii island has continuous lava flow. So geologists were studying the lavas and they felt that at one particular point of time, it was erupting a lava with very high amount of sulfur. And the magma was at high temperature, 1065 degrees Celsius. And there is a sulfide melt. Actually, if inside the magma, if there is sulfide melt, then only it can erupt. So that means people understood at a particular time a magma is becoming enriched in sulfur. It was only sending sulfur, silicate, silicate, silicate. Suddenly it sent a volume of sulfide. Then people wondering how is it possible? Then geologists felt that an immiscible sulfide, rich in liquid, which is equal to copper-rich pyrrhotite solid solution. Of course, now you don't worry about copper solid solution, copper-rich pyrrhotite. The sulfides were carrying very amount of copper-rich. So geologists felt that this particular part of the magma, when it came to surface, it quenched, and it gave rise to mixture of pyrrhotite, chalcopyrite, magnetite, copper nickel rich pyrrhotite. All these things were happening within this particular lava. So that means when the magma is there inside, it was sending only silicate, silicate, silicate to the surface. Suddenly, a particular stage that the magma became very rich in sulfide. That means the magma was undergoing some process, liquid divisibility, and a separate layer of sulfide magma formed. Is it right?
So,
So Watt was a scientist in 1926. So he studied this and he said that iron, nickel, copper sulfides are soluble up to 6 to 7% in a mafic magma. And he says that upon cooling of this mafic magma, certain minerals separate as immiscible sulfide droplets. Suppose you have a magma here, when the crystallization is happening, certain sulfide droplets will be there. They are immiscible and they will start accumulating. Accumulating a magma chamber at the bottom. Okay, this is something like a furnace, like people have studied, no, like copper smelting. People have seen in when they are melting the copper ores, they found that at the bottom there are certain components are forming, and rest of them are something else. Okay, molten copper at the bottom in a smelting furnace. At the top you have the slag, a lot of silica rich slag. At the bottom is the sulfide rich copper solutions. So this was correlated. Okay. And what are the melt is, you cannot be 100% pure melt. It will be having some mafic rocks, no doubt, but the sulfide composition is high. So such a thing happens in case of sulfide immiscibility. So what exactly happens? As magma cool, the magma can split into two liquids, two types of melt of different composition and density. One of the liquid is silica rich melt. Yeah, yes. Okay. Suppose this full magma, it's split two. One is the silicates. The top you will have all silicates. High volume. This is a sulfide, low volume. Silicate has got the high volume, a smaller volume. So this can be either a metal oxide, it can be a sulfide, or it can be carbonates. It can be anything. So because of this, you can have different types of immiscible melts. You can have oxide melt, immiscible melt, can be rich in iron, titanium, forming ilmenite, FeO, TiO2, hematite, sometimes magnetite, ilmenite. Spelling is ILMENIT. Spelling wrong. Not ilmenite, it's ilmenite, MENITE. Okay. You can have sulfide immiscibility, is oxide immiscibility, can be rich in nickel and copper, platinum sometime. The major mineral is pyrrhotite, iron sulfide. This is the sulfide immiscibility. This is oxide immiscibility. This is carbonate immiscibility. Carbonate melts. Niobium, tantalum, rare earths, copper, thorium, phosphorus. Have you heard of carbonatites? Anyone of you? Carbonatites? Anish? Anish Shugotra?
Yes, sir.
Have you heard of the term carbonatites?
Yes, sir.
Can you tell me what is carbonatite?
It is a kind of igneous rock which contains greater than 50% of carbonate minerals.
Very good, very good. बहुत अच्छा, बढ़िया, fantastic. I am very happy. Kanish, let me write down your name. मजा आ गया. Kanish, मजा आ गया. KNISHK, Kanish. Very good. Can you tell me a place where this carbonatite occurs in India?
India. Hmm, I'm not sure, sir.
Not sure. Did you study about this rock type last year in English petrology?
Yes, sir, in not much of detail, but I have heard of the carbonite.
So can I talk to Lamina? Lamina is there? The class? Lamina? Lamina is put on the computer and is sleeping, I think. Let me note down. Lamina, cut off. Okay, next. Let me talk to some other student.
Yes, sir.
It is Bharat Singh.
Yes, sir.
May I know Mr. Luna Lunsawat Bharat Singh? Bharat Singh?
Yes, sir.
Can you hear me?
Can you tell me a place where you have carbonatites in India or anywhere in the globe? Prajwal Sahu?
Yes, sir.
Prajwal Sahu?
Yes, sir.
Have you heard of carbonatites?
Yes, sir.
So can you tell me a location in India where we get carbonatite?
So not sure, sir.
Did you study carbonatites in your second year?
So just the like classifications, not in much depth.
Acha, okay. Can you tell what are the minerals present in carbonatite?
So the carbonate, the condition for it is that the carbonate is more than 50%.
What is the carbonate? Is it magnesium carbonate?
So car,
Is it magnesium carbonate?
yeah, so I think magnesium carbonate will
God.
also
Oh
be.
God. Oh God. You are gone. You are gone. You are gone. You are gone. That means you do not know anything about carbonatites. Do not know anything about carbonatites. Very sorry to say this. Sadhu, very sorry to say this. Can I talk to Saket? That means you people do not know anything on carbonatites.
Yes, sir.
Saket, can you tell me what are the minerals present in carbonatite?
No, sir.
Good, very good. I like this type of answer. Yes. He said no. Very good, very good. What is the grade that you got in Igneous petrology?
9.
9. Very good. Wow, wow. Great, great, great. Great, great. Okay. Anyhow, please read. All of you, to whomever I ask the questions, please read about carbonate. It's a interesting rock type. It has got excellent academic interest as well as exploration interest. Recently, throughout the globe, people they look for carbonatites because it consists a lot of rare earth elements. It's written there, you see, rare earth. Lot of rare earth minerals are there. Very important. Please read. Okay, so what are the types of deposit that forms in this type of liquid immiscible process? You can have pyrrhotites, alkopyrite, pentlandite, nickel bearing. Okay, these are copper nickel ores. You can have platinum also, gold also, silver. Okay, and most of them are confined to mafic rocks of gabbro family, gabbroic. Okay, liquid immiscibility. Okay, and these are disconnected bodies. They are simple mineralogy. The most classical is the nickel copper sulfide deposit in Zizwa, that is South Africa. Then you have nickel sulfide deposit, Bushveld in Norway. So this is Bushveld, and you do have Norway also. This is South Africa. Nickel sulfide in Bushveld. Okay, Norway is a separate country, Scandinavia. You do have in Canada called Sudbury, and of course recently people talk Norilsk. That is in Russia, Norilsk. Norilsk. Somehow, unfortunately, in a country like India, so far we have not been able to discover any copper nickel sulfur deposits. People have been trying. So we have not got a suitable environment for the formation of this type of copper nickel sulfide deposits. We have chromites, we have platinum, we have diamond, but unfortunately, you do not have nickel copper sulfide deposits of any of these types. Okay? So here, once again, you can have a segregation, you can have an injection. Done? आज का class. So I did interact with a lot of students like Akshit Punia. I interacted with Amit Srivastava, Kanish, Prajwal, Saket. Of course, some of them I tried to talk to them, but they were not able to respond. Doesn't matter. I have put across. No problem. Doesn't matter. Next time you respond. Be alert in the class. Okay. Be alert. Be sincere. Okay. What are the people
right now, sir?
No problem. Okay. Dakshit Jaglan. Yeah, I tried to track Jaglan, but he also went out of he left the meeting in between. It's all right. Doesn't matter. It's all right. Doesn't matter. Sunrise in the morning, sets in the evening. Nothing stops. Things keeps on moving. Okay. All right. So, itna sincere, utna acha. Let me see how many participants today. 33 participants. Okay. Still, 30 participants are not there. Okay. I feel. Anyhow, I'm noting down some names.
Sir?
Come to yeah, please.
So I had a doubt, sir.
Who is that? Who is speaking?
Sadaksh. Sir, I'll
Yeah,
switch on
please.
my video as well.
Please tell me.
So we were talking about liquid immiscibility. So what is the exact principle behind the development of the layer? Is it just the density variation or the different temperatures of cooling down of different minerals?
Did you see the presentation, my presentation? Did you see my presentation?
So not right now, sir.
That is the problem because you did not follow. You did not follow.
No, sir, I had a doubt in between. So liquid immiscibility of oil and water happens just because of density variation. You talked about temperature variations as well, and you said that density variations are there as well in both the sulfide layer and the rest of the silica layer. So, but what is exactly like, is the amalgamation of both of those things responsible for the development of the layer, or is it just one of the factors?
Okay. Let me show that slide. So, okay. This is the picture that is shown. Okay.
Yes.
All right. So people studied Hawaiian lava. People studied Hawaiian lava. Okay. That was a classic example to understand how the immiscibility takes place, why certain particular lava is rich in certain chemical components or in terms of mineralogy. Okay. Done. We are not seeing, these are observations. Okay.
Yes, sir.
Okay. All right. So what is the explanation that is given? To start with, by Watt, 1926, very old. He says that to start with, iron, nickel, copper sulfides are soluble to certain extent. That means they are part of the belt. It is there in the belt. You cannot distinguish. Belt is there, it's dissolved, it is soluble. Okay. You cannot have a distinct phases of sulfides. It's all dissolved. Upon cooling, so that means at high temperature, they are miscible. When it starts cooling, it separates. So temperature does play a role. Okay? All right?
Yes,
so
sir.
The corollary was the furnace. At the bottom, they found certain copper based solutions. At the top, they found the silicate belt. Once again, it's a correlation. Is it right?
Yes,
okay?
sir.
What is it? What is this? Can you please read?
As magmas cool, they can split into two liquids of different composition and density.
Yes.
Okay, sir.
So that means temperature plays a role. At high temperature, they are miscible. When the magma cools, it starts splitting. This is called as magma splitting. There is something called magma splitting. There is something called magma mixing. So for this, you should have the strong background of igneous petrology.
Yes, sir.
So Jaglan, since you initiated this discussion, I will give you a 15 minutes talk. Okay? Next week, Monday, you will give a talk on magma mixing and magma splitting.
Okay, sir.
Okay, done?
Yes, sir.
Excellent. Very good. Very good. It's clear?
Yes, sir.
Okay. Okay. Good. Very good. Very good. I'm happy. Yeah, this is what I like the interaction. Yes. He was able to have the question and he was able to answer. And because of this, a lot of things becomes more clear. Jaglan, where are you from?
Sir, I am from Chandigarh, sir. But sir, I was living in Udaipur for the past couple of months.
Very good. Udaipur is a good place for geology.
Yes, sir. So the answer to that, where you said carbonatite can be formed, sir, I heard that it was found near Amba Dogar, sir, in New Udaipur, in Gujarat.
I think probably you must have Googled by this time.
No, sir. This happened when, sir, we were having a discussion with Sir D.K. Srivastav, sir. He said that explore a little bit more about what is.
Not D.K. Srivastav, it was D.C. Srivastav.
D.C. Srivastav, sorry, sir. So he said that explore about Udaipur ki the geology in particular.
Yeah, very good. But anyhow, your carbonatites are far away from Udaipur.
Yes, sir. So they are in New Udaipur in Gujarat.
That is in Gujarat. That is totally different. That's a part of the Deccan basalt, whereas Udaipur is a part of the Precambrians.
Yes, sir.
Anyhow, I'm happy. At least I could see that, yes, you have interest. Anyhow, you keep interacting like this. And I have given a topic on magma mixing and magma splitting. Okay. So next week, Monday, we will give the talk. Good. Very good.
Sure, sir.
All the best. All the best. So I did interact with some students. I have noted down some names. I have seen your response. Yeah, this is how the class would go on. Thank you so much. The time is already 5:04, and we will meet on Friday. All right. On Friday we'll meet. You people can leave. Yes.